Hello, everyone. So in this part of the lecture, we will talk about waste to energy systems for the treatment of municipal solid waste management. As you know, we talked about recycling, recovery, and we also talked about material recovery facilities. So once we realized that a good amount of waste which cannot be recovered or recycled, and we do not have any other alternate to deal with that waste. So uh, in that condition or in under those circumstances, we sometimes find or we sometimes use incinerator as a technology for the disposal or treatment of the waste. So what is basically incineration? As you know that I told you that chemical methods are the in the chemical methods, the incineration is one of the important technology. Basically, it's a combustion of your municipal solid waste. So how it's done? For example, this one is showing a what we call a grate incinerator. It's a this is what the grate is. It's basically a system in which you put your waste from a hop from a hopper, and these grates allow this waste to move. You pass air from the bottom so that the combustion or oxidation of waste take place here, and the flue gases which goes out through different air pollution control devices. So this great incinerator is one of the technology which is widely used as an incineration technology for the treatment of municipal solid waste. So if you see, in fact, although it looks so simple, but if you see the modern incineration waste systems, they all are waste to energy system. So what is the meaning of waste to energy system? Because we are uh, doing the combustion of municipal solid waste. So therefore, there is a thermal energy produced, which can be used as a steam to either to run a steam generator or using for different processes. So here the concept is to incinerate the waste, produce thermal energy, and use it to generate either either electricity or use steam for different processes. So the modern systems has different components. For example, the great incinerator is here, followed by the steam usage like steam turbine and then generator. And those flue gases, because these gases will contain several of the toxic gases or harmful gases, and they will contain acid gases and particulate matter. So they cannot be released without treatment to the atmosphere. So therefore, there is a series of air pollution control devices which we will be using so that the flue gases are clean before they go to the atmosphere. So the modern waste to energy system or modern incinerators consist of a mechanism to extract energy as well as to treat all the flue gases coming from the combustion process so that it do not harm the environment. So if you see, let's have some discussion on advantages and disadvantages of an incineration system. Most suitable for high calorific value waste and pathological waste. What does it mean? So, for example, as you know, this is a combustion process. So any kind of combustion process is more feasible and practically possible when the calorific value of the waste is high, because ultimately you are burning it, you're using it as a fuel. And if there is some kind of pathogens, etc., obviously they will be because the incineration occurs in more than 900 degrees centigrade, so that will be burned out, and therefore it's a good method in that sense. But let's pay some attention to whether this system is good for Indian MSW. As you know, as you have seen in the characteristics of our Indian MSW, so in Indian MSW, a good amount of our waste is either food material or food waste, and it has high moisture and therefore most of time very low calorific value. So in many times it will not be even possible to do the combustion without supplying some auxiliary fuel. So that would be a disadvantage for, because our waste is aqueous, high moisture content, low calorific value. So in a sense, it may not be that much suitable for Indian MSW with respect to calorific value and high moisture. Units with continuous feed and high throughput can be set up. What does it mean? So basically, you can have a continuous system where your waste is coming, so and you are incinerating it in and producing the ash. So it's a continuous process in a sense, because many of the processes are intermittent or even in batch scale. So here you can every day, every time you can bring the waste, keep on feeding it, and it can work continuously. So this is in a sense a good system with respect to that. That means if you are talking about a lot of waste and you do not find other um, suitable technologies, therefore this insulation can be used. However, if the excessive moisture, inert content affects net energy recovery, auxiliary fuel support may be required to sustain combustion. As I already mentioned, if the moisture is high, it's going to be a problematic. Thermal energy recovery for direct heating and power generation, because we are now in an era where the energy to find the renewable source of energy and find a sustainable energy system is required. And because a good amount of of municipal solid waste, especially food waste, etc., it is renewable in nature. So therefore, a good amount of the energy, if you extract from incineration, that would be the renewable energy. However, when we burn this waste, there are many toxic gases, and that can hamper your environment. Low land area requirement as compared to the other conventional technologies like composting. However, the capital cost and operational maintenance cost is often quite high as compared to other technologies. Can be located within city limits because it's a low land area requirement. So therefore, you can put it in the city domain itself, and of course then the transportation cost would be reduced. The disadvantage is required skilled personnel for operation and maintenance, so therefore you need to spend more money and you need more skillful people to do the job. It's hygienic. That means, what is the meaning of hygienic here? Because many components of municipal solid waste also can contain pathogens and other bacteria, etc. But once you do the combustion at 900 degrees centigrade, at least there won't be any issue with respect to pathogens, bacteria, and etc. because they all will be gone. And overall efficiency is low for small power stations. So efficiency is because, please remember that this is not the best fuel. The municipal solid waste is not a best fuel. It's not coal. It is non-uniform in nature. It's heterogeneous in nature. So overall, this system has very low efficiency. So therefore, it may not be the best way of producing energy or electricity. Now let's look into the emissions which are coming from incineration. That has been a major concern whether we should go for this technology also in addition to its other practicality issues. So you must have heard that when we do combustion or incineration of municipal solid waste, it produces many of carcinogenic and toxic compounds. Some of them fall under the category of dioxin and furones and polychlorinated biphenyls. So there has been a lot of concern about these dioxin and furones because they are, in a sense, carcinogenic, one of the most toxic compounds which are produced. And then there are others, volatile organic compounds, aromatic hydrocarbons, chlorinated benzene, etc. They also may emit to the environment if we do not have proper air pollution control devices. Along with that, there could be many heavy metals which may be going to the atmosphere, and there will be acid gases produced, which can be which are basically essentially the pollutants, as you must have studied in the air pollution component. And these many of these components, they are in the solid form like particulate matter, either PM2.5 or or PM10, and you must be aware about this ash generation from the combustion. So there would be fly ash, which could be containing all of these compounds. When you use air pollution control devices, especially wet exhaust gas cleaning systems, what you will do is you will produce wastewater, which also need to be dealt further. And it may contain many of these compounds and many of these heavy metals. So in that way, you will see that what is the advantage of incineration. It can do mass burning. You can bring all the waste. It reduces the volume in a big way. It reduces the mass. It is reliable system. You can run it continuously. But at the same time, if the calorific value is low, you have to put auxiliary fuel. That means you, instead of producing energy, you are giving more energy. If it could be expensive, there are air pollution control concern. However, the modern incinerator have very good air pollution control devices, but that also makes them a little bit costly in terms of the operation as well as in terms of their construction. Another similar technology is gasification, where we, instead of completely combusting the waste, we partially oxidize the waste uh, into gaseous fuel, as I told you in the previous part of the lecture, carbon monoxide and hydrogen. And that means your waste is basically converted into a synthetic gas, and which can be used at fuel. This synthetic fuel can be used for either to generate energy or electricity, or can be also used to synthesize different products. So gasification is a basically partial oxidation. It's comparatively new technology for municipal solid waste. The one reason for that is because our waste is so heterogeneous, so standardized. This process has been very tedious. So therefore, we were not able to have a big success in terms of gasifying the municipal solid waste. And sometimes even the scale is concerned, because you produce that gas, you have to clean that gas. So there is not much application so far of gasification, but fundamentally it could be one technology which has a lot of advantage. So if, for example, what is shown here, you have a tipping floor where the waste comes. You recycle metal, glass, other materials, including plastic bottle, etc. You prepare the waste, put it into gasifier. Temperature is shown here 750 to 3000 Fahrenheit, depending upon the type of the gasifier. The synthetic gas, which essentially contains carbon monoxide and hydrogen and other components, it's cleaned up, and then this gas is used as a fuel or for electricity generation. And then it's not shown here, but there could be some particulate cleaning and some series of gas cleaning system which would be required. And the inert solids and this can be used for the as a construction material with some kind of specific treatment. So this is the gasification, in a sense, an alternate to the combustion, but several limitations. One of them is its high cost, and because of the heterogeneity of the waste, sometimes it's not easy to control or regulate, control or operate these systems. Another possible method is also there, pyrolysis, where you do thermal distillation or thermal destruction, and you produce pyrolytic oil. Especially for the plastic waste, people have been trying to optimize it so that you can do the pyrolysis and convert your waste, especially the plastic waste, into pyrolytic oil, and that can be used as a liquid fuel. So this is all what I have to tell you about the waste energy systems. We talked about what is the meaning of waste energy system, how the modern waste energy system look like, what is the mass burning great incinerators, what is gasification, and where the gasification stands. I will stop here, and in the next part of the lecture, we will talk about the disposal of in sanitary landfills.